Hi guys, so today we'll be solving this problem called kth largest element in an array. Let's read it. Given an integer array nums and an integer k, return the kth largest element in an array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay, so we can see that we've been given an array and we've been given a k value, which is the kth largest element we need to find from this array. The first approach that comes to our mind would be sorting the array and then returning the n minus k plus 1 element from the end and returning that. But the problem here is that it is going to be a distinct element, right? So it needs to be a distinct element. So when we sort the array, there might be duplicate elements, so it would be sorted in an order and such that the kth element would be a duplicate element, not a distinct element. So we can do one more thing, is that we can put that this array into a set so that we have unique set of elements, and then sort that, then return the n minus k plus 1 element. But here the time complexity would be O of n, and as O of n log n, because we are sorting it, and as well as the space would be O of n because we are putting it into a set, right? So that is not a good way to solve this problem. The other approach to solve this problem would be uh, by method 2, which would be by using a heap. Now we know there are two types of heap. One is max heap and another is min heap. Okay, so max heap is basically the largest element is at the top of the tree which is formed. For example, 8 is the largest element. It would be at the root of the tree, which is at the top. And in min heap, we have the smallest element, which is 1, or for example 0, whatever the smallest element would be, it would be on the top or the root of the tree. Now for a heap, it should be a complete binary tree, and it is basically a complete binary tree, and the root element is either the maximum element if it's a max heap, or it is a smallest element if it is a min heap. So we can do this problem by both max heap and min heap. So how we can do it by that is, first one, let's say we have a max heap. If we take a max heap, we store all the elements in the heap. So if we store all the elements in the heap, then it would be say 6, then 5, then 4, then 3, then 2, and then 1. Okay, so this would be the order of the heap, how it would be stored. And we will pop out k elements from the heap and get return the kth element. Okay, so 1, 2, so 5. So 5 would be the uh, kth element, and it would be returned. Okay, so this is one of the approach. The second approach would be by using min heap. So by using min heap, what we can do is that we can create a min heap, and say for example we have this 3 2 1, writing it again here, 3 2 1 5 6 5 6 4 4. Okay, so now if it's a min heap, then the smallest element would be at the top of the heap always. So let's try to run this on this array. So 3 would go, then we come to 2. So 2 is smaller than 3, so it would be at the top of 3, then 1. Okay, so now what we need to do is that we need to always maintain the size of the heap as k. Okay, so the k is 2 here, so we need to always maintain the size of this heap as 2. Okay, so now we have 1, we push 1, we see 2 is smaller than 1. Okay, so we have 1 at the top. Now we check if the priority queue or the heap dot size is greater than k, then pop heap.pop, like pop the top element of the heap. So we see that this size has become 3. So we pop out the top element. Now the heap has 3 and 2 in it, and we are here now. Now we see 5 is greater than 2 and 3 both. So it would come down and it would be here. Now we check this condition, which is heap.size. If it's greater than k, then heap.pop. So we see that the size is greater than 2. So we pop the top element. Now this heap would be 5 and 3. Okay. Now we come to 6. Now 6 is obviously greater than 3 and 5. So it would come here and we check the condition again and we pop the top element. Now we have 5 and 6 and we reach the last element. Now we see that 4 is in between of 5 and 6. So 4 would be here. We have 5 at the top. We return 5 because 5 is the second largest element in the heap. That's how we have to do this. So we reach at the end and we return basically pq.top in the end or heap.top in the end. Okay. So that's how you have to do this problem. Let's try to code it and we'll be coding it in C++ and let's see how it goes. Okay, so we've been given a function in find kth largest element. Let's write some code. So priority queue vector int greater int pq. Okay, now so what I've created is min heap. Okay, now you've basically in C++, you usually have the default priority queue as a max heap. So you need to write greater int to make it a min heap. Whereas in other programming languages, it is min heap by default. So first of all, what I do is that I iterate through the whole array and I do pq dot push element. Okay. And as I said, I check pq dot size is greater than k, then you do pq dot pop. Okay. And that's it. That's what you need to do here. And we'll be basically popping that element out and we'll be basically pushing all the elements in the array, in the heap. And then at the end, you return pq dot top, which is the last element that we have put. So let's run the code to see if everything is working fine. Yeah, let's submit it. And that works. So I hope you guys understood the problem. Do solve it and do subscribe to the channel. And yeah, see you next time. Bye.